Hi everyone. Thank you to Stella who reached out and asked for some help and some clarity on describing the relationships when we're drawing scatter plots. So in this video I'm going to quickly run through how we talk about the correlation in relationships. So these questions that I'm going to go through are straight from exercise 9G. And what they're talking about is the relationship positive, negative, strong or weak? So let's actually just look at that in a little bit more detail. Pretty much when we draw a scatter plot, if we can see a pattern, that suggests there's a relationship. So in this graph I've just drawn, there's clearly a pattern going up like this. And that pattern has a positive gradient, so we call it a positive correlation. So by that, then very quickly, we can say if it's going down, then it would be a negative correlation. It's that simple, not rocket science. So what does no correlation look like? If I've got no correlation, that is pretty much when I plot the points, there is no obvious trend. So I can't really say, is this going up? Is it going down? There is no correlation. So let's go a step further. I know the first question we're going to look at doesn't ask for this, but I can have a positive weak correlation. So here, there's clearly a trend going up, but my dots on my scatter plot are quite spread out. So this would be a weak positive correlation. Whereas if I have those dots really quite closely defined in a straight line, they're not spread out, this would be a strong positive correlation. And the same thing works for negative as well, it's just going in the other direction, so I'm not going to write them down. The question in the textbook said, by completing the scatter plots below by hand or using technology, I've used technology, for each of the following data sets, describe the correlation between X and Y as positive, negative or none. So in this first graph here, this was part A. I'll just put that up the top. Part A. I can see if I wanted to add a line of best fit, it would probably look something like that. My dots here are relatively close together and it is clearly going down, so I would call this a strong negative correlation. Now the question didn't ask for the strong part, but since I'm making the video, I might as well include it. For part B, same thing, there's a clear trend where the graph is going up. So I would call this, and I'll just write this as part B, this would be a strong positive correlation. Okay, now these are still in the strong strand. If I had, say, a few extra points out here, then maybe I'd be starting to consider that that is a weak correlation. I can still see it's going up, but I've got more spread in my data. Let me get rid of those points because they weren't part of the question and I don't want to confuse everybody. Okay, let's move on to the second question from exercise 9G. That was number 5. For common motor vehicles, consider the two variables, engine size, cylinder volume, so the engine size, how big the engine is, the volume of the engine, and fuel economy, number of kilometres travelled for every litre of petrol. Do you expect there to be a relationship between these two variables? And I'll just zoom down so you can't see the graph yet. So what they're asking, do we think there will be a connection between how big the engine is and the amount of litres of petrol that are used for that engine for every kilometre? And I would say yes. The bigger the engine, then the greater the volume of the engine, then I'd expect to put more petrol into a larger engine. So, yes, I expect a relationship. As the engine size increases, would you expect the fuel economy to increase or decrease? So same thing, I think as the engine size increases, I expect to use more fuel. So more fuel is less economical. More fuel equals less economy. So we've got to use our general knowledge here and link it to what we know about what happens in the real world. So as engine size increases, I actually expect the fuel economy to decrease. I expect to use more fuel, so it's going to be less economical. The following data were collected from 10 vehicles. Here's my data. Do the data generally support your answers to part A or B? Right, well, rather than just looking at the numbers, I've put it into a scatter plot. So I can say, does it generally support my understanding? On the bottom here, the independent variable is the engine size, because that's making a change to the amount of fuel. And it seems to be that there is a trend going down here, and most of those values kind of fit that trend line. I might even put my trend line sort of more like this to get closer to those points over here. There's pretty obviously though, this value here seems to fit outside of that quite significantly. So do the data generally support your answers to A and B? Yes. And I'll write down here, appears to be a, now would I call it strong this time? I don't want to call it strong, I don't want to call it weak. I'm actually going to go in between a moderate negative relationship. And this one over here, I'm going to say is an outlier, because that one doesn't kind of fit the rest of my trend. So which car, there's the bell, sorry, I'll just wait for that to finish. Which car gives a fuel economy a reading that does not support the general trend? It is absolutely this car here. So that is the car with an engine size of about 3.3. So if we look up in our data set, here's my engine size that is 3.3. It has relatively high level of economy. So car H does not support the general trend. Could be an outlier. It could be dodgy testing. There was a whole scandal with VW and their testing criteria for fuel economy. So maybe this car is part of that scandal.